Welcome to the 122nd video in our series about Unix tools. In this video, we will continue to look at a mysterious 2012 archive and see if we can get the code stored within it to run. In video, which I have misspelled, video 121, we worked on fred.c. And this time, we're going to look at the fred.py Python code. You know, there were 4 files, and we'll look at each one by one. So let's do it. If we take a look, we do have a fred.py. If we look inside, you know, we can double check, make sure it's Python code. It says it's Python 3 code. That's what it says. And it says it's a line editor. Oh, wow. And you can see it's got H, E, L, D, and A. It's got the same commands as the C code does. So let's run it and see what happens. Since it's a script file, the permissions are not going to work. We need to add execute permission. So I'll be brave and let everybody run it. And you can see I've added execute permissions. So let's run fred.py and see what happens. That it looks the same. If we say H, we get the same sort of thing. So let's edit simple.txt. Let's list. Let's try delete 3 and see if it works. It does. It doesn't share bug for bug compatibility with the C program, which is just as well. We don't like bugs. Let's delete the first line. Let's delete the last line. Let's delete everything, which is D. Are you sure? Yes. And it said delete of entire buffer aborted per user request. Even though we said yes. So something fishy going on here. Let's use uppercase since we were doing everything uppercase and just put a Y. Okay, so it works if you stick with uppercase single letter response. We haven't tested range deletes yet. So let's get out. Let's go in. Let's try the one line range, which that works. Let's try some lines from the middle, 2 and 3, but not the beginning or end. That works. Okay. Let's go in again. Let's delete 1 through 3. Which includes the first line but not the last. That works. Let's delete 3 through 5, which includes the last line but not the first. That seems to work. Let's delete, using a range, everything that's in there. That seems to work. Let's try the 4 to 2 thing. Oh! Okay. It didn't do anything bad, but it just didn't do anything at all. So clearly we need that range check that we added to the C program, added to this program. Another bug we had in the C program, which we haven't fixed yet, is what happens when you put in a file name that doesn't exist. Okay, this one crashes just like the C program crashes, except if this is Python's version of a crash. It's called a traceback. Okay, no such file directory, and we crash hard. So the delete seems to be a little bit better. This didn't do anything bad. but it didn't give a message, and we'd like it to give a message. The E does the same thing as the C code does, which is fail miserably. Okay, the C code, one problem we had was it didn't have many comments explaining any of the logic. So, is the Python code just as bad? It's written in the same era, 2012. So, it may be just as bad. Let's take a look. Oh, it's written by the same guy. This guy must not know what he's doing. Yeah, but at least it's free and open source. We get the source code, we can fix it. Keep in mind these examples were written for class, and the idea was the students would hit the bugs and debug them. Sadly, the students tended to say, oh, the teacher wrote it, the code must be perfect. So, oops. Anyway, the indentation doesn't have the tab problem, but otherwise, this code looks just as bad as the C code, except it's a lot shorter. Python has the built-in types that C doesn't have. Python has a native list type, so no linked list has to be implemented, and that's probably why there aren't any pointer bugs in this one, but it still uses regexes for the ranges. It tries to be as close to the C as it can, but still be smart and use Python features. So while we're in here, we have two problems that we know we need to fix. Let's tackle the first one. In Fred.c, oh no, the C code's back. In Fred.c, we added a new error message about ranges when we did the delete. So somewhere. Here it is. Okay, is range insane? This stuff. We need this message and this test in the Python code. So if we split for Fred.py and we take a look, what's the name of this function? Del command, not delete command, del command. Do we have del command? I mean, how similar is this code? We do, del command. So we come down here. Let's take a look. Did we have something about valid line numbers must be integers? Okay, so those messages are the same. And then it just jumps into the del. Okay, so they don't have this. They also don't have this, but that's not going to be a problem in Python. But we need to add this other test. So let's come up here and do it. If end less than start, and let's take a look at this. Copy the style. No matter how bad it is, we should make it look the same as the other code in the same program. Okay, print end. Oh, you know me, I'm going to have a typo. Let's just copy it and be safe. And Python's print statement puts the new line for you. We don't need the semicolon in Python, and we should have a return at this point. So we should have the same message in the same situation. So when we say D4 minus 2, it should say end of range, cannot be less than start of range, and we should return and not even attempt to delete. Okay. Sounds nice, but is it going to be nice? You never really know till you test it, right? Oh no, indentation error. Unindent does not match outer indentation level. This is one of those Python things. So you look at line 72 and you say, that is exactly the same. Turn on the listing and you're going to find out, oh, this Python code used tabs, okay, instead of spaces. In the C program, most of the program used spaces and they had one place with tabs, so I expanded all the tabs. Here it's the other way around. 99% of the program is tabs, only our new code doesn't have tabs. We need to use tabs. Okay, it looks exactly the same, but it should clear up the unindent error. Okay, good. Let's edit simple.txt. Let's list, let's D4 minus 2 and see if we get our message. We got our message. Did anything break? Nothing broke. Awesome. So we've made the same fix we made in the C code about ranges where the start was greater than the end, which is the same thing as saying the end was less than the start. So, wonderful. That debugging was a lot quicker, and it's one of the reasons why many teachers don't like to teach C anymore. They'd rather teach the students Python to begin with, because Python just doesn't have those pointer bugs. I agree, as a first language, Python's a great choice. Sadly, at least at my school, they don't later make the students learn C or C++ that's got pointers and requires more discipline. I think that's a necessary comp sci skill, but it is not marketable at this time, and so our school has decided to emphasize marketable skills, and I think that's the modern way, and it helps the students get a job. So I understand the logic why they do it, but it also means that there are classes of bugs these students are not prepared to handle. Okay, speaking of bugs we can't handle, I cannot handle, okay, we need to fix that. And then we need to go back in the C program and fix the same thing. Since we've got some time left in this video, let's attack it. So the first thing that we'll notice is I don't have to worry about where's my core dump file, because the traceback tells me what I need to know. It says I attempted an open on line 93 in the edit command function, which was called in the main on line 115. And, you know, always start from the bottom and read backwards. And the bottom is telling you, file not found error. That's an exception. And you should cut and paste that. And you know, on Windows, you have to hit some special keys to make sure it really goes into the clipboard so you can get it back. Okay, let's go fix it. Clearly, we need a try block. And if we look, I bet we won't see one. Line 93. Let's do it. What's the name of our program? Fred.py. So we go to line 93 and we see, oh, there's no try block. What idiot did that? I think, and remember, we've got to be careful about tabs. So let me do a set and see what I've got here. I've got expand tab. I don't want that. Set no expand tab. Okay, so now when I type a tab should really be a tab. So there's a tab, and then I'm going to say try, and I'm going to come down here and insert a new tab here, and then we can do accept, and the bug we had was, oh, I lost it. File not found error. Okay, and you could put the exception into a variable, but if you look at the message, it didn't really tell us much. You know, file not found, and the error message was no such file. Okay, so that doesn't tell me anything new, and it also printed the name. We know the name because we've got it in the variable f name. So there's no real reason to put the exception anywhere. We just need to catch it. File not found error, what are we going to do? We need to give a message. And we can't copy the message from the C program because the C program has the same bug. So we're going to say print no such file. We should probably use an F string. We don't want to go back and spend the time updating all the old code right now, but at least when we write new code, we can use F strings. F strings didn't exist in 2012, so I don't think. So they're not used in here. They were using this kind of thing with the format instead. So no such file, exclamation point. Okay, that looks pretty good. And we need to be careful with our quotes here. If we want double quotes inside, we need to use single quotes outside. After we print there's no such file, we should do what? What should we do? Should we return? There's no other error in here for us to look and see what's going to happen. So let's find out how edit command is called. Edit command is called, and then we come back to the command loop. Okay, so that means that if we had this and we return, we'll just come back to the command loop, and lines is not cleared until after the open succeeds. Since the open did not succeed and we caught it first, when we return, lines is not affected. So whatever was in lines before is still in lines, and if it was empty, it remains empty. Good. I'm happy with that. Let's test it though. It's easy to talk yourself into believing, yeah, that's reasonable, that's going to work. But the only way to be sure is test, and test some more. This is why I don't like tabs in code. But a lot of people do. And like I said, when you go modify some old program, unless you're going to rewrite the whole thing, just match whatever style they're doing. And we're still getting errors here. And so now we have to ask ourselves, why is that? And if you do a set, you can see I set the expand tab in my VIMRC. So every time I start VIM, it's wiping out the allow tab setting. It's my own fault. Okay, so I need to set no expand tab, set list, and come in here and put the tabs. And I've got too many. There we go. So let's do something that works and then do something that doesn't work, because that's what we did last time. So we had simple text, we did a list. Now let's edit stupid.text. Hoy! No such file directory, stupid file not found error. During the handling of that exception, another exception occurred. It says name file is not defined. So I put the wrong variable in my F string after doing lots of promotion about how wonderful F string is. I'm sure it's wonderful, but you have to use it correctly. What am I doing wrong here? It's supposed to be F name, not file. Okay. Maybe I need to do a little less talking, a little more coding, but then you'd fall asleep. Stupid. Finally, no such file, stupid. But of course, we haven't loaded anything into the buffer, so we don't know if that cleared the buffer or not. So we need to load the buffer with something, then do the stupid thing, and check to make sure the buffer's still okay. And the buffer's still okay. And then if we load something that really exists, the buffer should change. And it does. What happens if we try to delete that blank last line? Seems to work. So we fixed the E command for the Python code. And we put in better logic for insane ranges where the start is greater. Was it? Yeah, start is greater than the end. And we now put a message up like we should. Okay, we've fixed the Python code. It was a lot easier to fix, and like I said, that's because Python has stronger built-in data type for lists, and we don't have to implement that. Okay, in the previous video, we worked on the C code a lot, and I wanted to show post-mortem debugging and could not because the core files in Ubuntu are apparently hidden. So I did a little research. Let's take a look. Okay, we did this part. We did this, okay, and I double, triple checked it. You can look in the video. I did that. And that's all you need on real Unix. Unfortunately, Ubuntu has decided that everything has to be obfuscated and 10 times more complex than it ever was before, and they're part of the nanny state. You know, they like System D. I mean, that ought to tell you something right away. But ranting is not helping you, is it? So let's scroll down. Update. Wait, where are the core files? And it tells you you have to go look here. Okay, why? Why do they put them in there? God only knows. But they do. So let's see if we can find the core files. We know we had 3 crashes that generated core files. So if we take a look in that directory where they said to go look, you can see there they are. And they have these really stupid names that would be hard to track down. But you can sort of get an idea. Okay, here it was called Fred. This one was Fred Debug, and Fred Debug crashed again. And they try to, you know, they encode the path, but they don't use slashes. They use underscores in home John Wednesday, Fred stuff. Who knows what the hash is? I don't know. And, you know, this is probably a PID or a timestamp or something. This is not the way Unix should work. Okay, this is un-Unixy. Unix is supposed to generate a file called core. Always the same name, always in the current directory wherever you were running it. Some newer versions do core dot and then the program identifier. I can work with that, at least I can find it. But this. So after I got that, I started following links around and I got to this web page of how to permanently edit the core pattern file and make things be like real Unix. It turns out it's some work. You have to go into systemd and then you have to disable this app port thing. And then you have to add a special file to set the kernel core pattern. And then you have to do this system control system. Well, only your system administrator can do this stuff. You probably don't have any control over this. I'm sysadmin on my machine, so I could fix it. But the whole point of this video series was, you know, you're remotely connected to somebody else's Ubuntu machine and you have to do application development of some sort. So you probably don't have root power. If you do, you can pause the video and take a look at that URL, and this will tell you how to fix it. And if you follow these steps carefully, it will fix it. But for now, what we're going to have to do is we're going to have to look here. Okay? And then use it the way Ubuntu expects us to use it. But wow, talk about, you know, there's user friendly, then there's just normal, and this is like anti-user. This is we hate you kind of obfuscated core dump location with obfuscated core dump names. End of rant. Let's go into Fred.c, and we need to fix the first bugs. Okay, so we'll grep for our GCC in Fred.c, and we're going to do what we did. This all worked fine, except we didn't like the O2. I'm being attacked. We got to go with O0, and then we have to add a minus G, and then Fred.c minus O Fred. Debug. And we created a debug version of Fred. And then if we run Fred debug, and we say e stupid.txt, we get a core dump. Okay, now we've seen these three. And we look at our date and our time, and we should find something at 6:19 p.m., which is, it's kind of dumb to say a.m. p.m. It should say 18 something, okay? 18:19:02. So let's go look up here and see if we can see something from 18:19:02. Oh, look at that. There it is. 18:18. That's got to be it. So let's see if we can do some post-mortem core dump debugging with our stuff or not. So GDB, Fred debug, and then this horrible long name. Okay. And, you know, what is all this stuff? This is just alien. All this debug info D. I mean, I don't want to send my embarrassing debug information over the internet. No, thank you. I'm trying to fix it myself. Okay. Program terminated with a signal aborted. So, type ret for more. Okay. I'm hitting return. Okay. And that's what I get. So let's try a backtrace. Okay, when we do a backtrace, this is different than in Python. Python puts the main at the top. C puts the main at the bottom. So main called edit command, and then that went into GI abort, GI raise, all this stuff. All this part from 4 from 4 to 0, that's in the system standard library. We can't do anything about that. So this is basically telling us, go look in edit command in Fred.c on line 245, and somewhere there maybe you'll get some information. So if we say frame 5, because it's number 5, that's where we called abort. And that's why I went in GI abort and did all this stuff. So let's do a list. Remember, list will try to center some lines around 245. Okay, and it says cannot open for reading, and it called an abort, which is a core dump. And that's not very friendly. Okay, that's really not very friendly. And the other thing is, I don't remember seeing this message. I just don't. And they did a delete list before they even tried the open. You know, the delete list should only happen if the open works. So delete list on 242, that needs to be after 246. And then if this test doesn't work, we shouldn't abort. We should probably return. Okay, and we know all this stuff is in Fred.c, and it's we need to start looking around 242. Post-mortem debugging is fabulous, but you have to be able to find the core file. So Ubuntu made it tricky, and the internet saved us with the browser. And I just did a search, and I found out, you know, this part I did because that's been the same since 1970 something. But this part, this is Ubuntu specific, and I found it with a search on the internet where Ubuntu, you know, long-term stable won't core dump, And then I saw this, where do I find core dump files? And I clicked on that, and that's where I got this web page. It's pretty easy to find. Okay, blah, blah, blah. Let's go into fred.c, and let's list, oh, goodness gracious. I don't know what's going on. So let's get down there. 245. Here it is. So I said 242 needs to move after 246 for sure. Oop. 242 move to 246. Why is that? Is that a bug? 242 move 246. Am I typing this right? There it is. Okay. Spooky. Then we don't want to abort. We'd like to return and leave the leave the list alone. Now, can we just return or not? Is that safe? I don't know. I think it's going to work, and it should cause us to return from edit command, and then edit command is here, and that'll cause a continue, and continue will bring us back to the top of our REPL command loop and show the prompt. So I think that's all we need to do. We need to compile again. Run Fred debug. Let's edit something that does exist, because we need to have an existing buffer to see if it got wiped out or not. Okay, cannot open stupid text for reading. Good. And our buffer's left alone, so we fixed that E bug in the C program. And we were able to track down and figure out what to fix using the post-mortem debugging with the core dump that we figured out how to find using the internet, because Ubuntu is not really Unix anymore and they've made it complicated. But a little internet help and we can do it. That's great. Let's take a look at what we've done. There are 4 files that we wanted to look at. We don't need this anymore. There were 4 files we wanted to look at: the C program, the Python program, and we've done those. The next thing is a Rex program, and that'll be in the next video. I hope you come back for that, and that you're still having fun learning about debugging in all these different cases. Until then, when I see you come back, thank you for listening.